So now that we have seen on a high level that what two different topologies will look like, now it's time to summarize or come at one certain decision or one certain uh, requirements when we jump into building a artificial neural network. In other terms, what are all the mandatory things to specify a neural network? So yeah, in other words, we can say what are all the things you will be saying that a given object is a bottle. There will be certain parameters, right? There are definite number of parameters which will be very much essential to say that particular object is a bottle or not. The first thing would be you should have a cap. It should be able to fill something into it. It should be either made of metal, plastic, or anything. So we have certain number of mandatory parameters, right, to decide what that object is about. Similarly, given any neural network, say it's a any topology, either regression or classification or any other kind of topology, we have definite number of parameters or different number of mandatory parameters in order to name it or in order to define before we start up building a neural network. So now let's have a look of those mandatory parameters which are very much essential to build a neural network. So there are six main things that need to be specified for specifying a neural network completely. The very first thing is the network topology, right? So it is very much essential to define or say it at the first itself that, oh, okay, this is a particular problem and the topology to solve that problem would be in this fashion. I have just taken two examples over here, right? Either regression or classification. So it is very much essential to define what is the topology of the network will be like, right? So how many perceptrons present in the input, how many perceptron present in the output, or like the basically that defines the topology of a neural network. So that is the very first thing we have to be very much sure before jumping into building a neural network. Then input layer. So what should be the input layer? So how it is very much special and what type of data it should receive, or if you take an input layer, what should be the number of perceptron in it, and what should be those perceptron will be doing, and what are all the type of input signal we can pass it to the input layer. So that is what we need when we start building a neural network. Then comes another important layer, that would be output layer. So it is also very much essential, right? As I mentioned, it is about network topology. Then it is very much sub included under topology as well. So it is very much essential to define what is input layer is about and what is output layer is about. Then we have other term called as weights. Weights are nothing but the importance of each and every input signal to the given particular perceptron. So if the weight associated to that particular input signal is high, then definitely that particular input signal matters a lot, right? It's a general intuition. If we have, for example, as I took an example of restaurant, going to a restaurant, then if your main intention or if your major weightage is about the cost, then the decision of going to the restaurant will be severely affected by that cost parameter. So the weight you give it to the cost parameter is high, then that makes that output of the complete the decision to go to the restaurant or not is severely impacted by the particular input signal. So that's why we have to define what are all the weights associated with each and every input signal. It might not be the just input signal. as I mentioned, we have also other set of layers in between input and output, that is hidden layers. There will be certain number of weights associated between the input layers, between those hidden layers as well. So we will study about these things in the further sessions. Then activation functions. So activation function is the one which is present, or the equation present in the output layer. So this activation functions would be generally the mathematical expression present in the output layer, which will be deciding whether to sum up or we have to multiply it. Like the output signal will definitely receive certain sum of input signal, right? So the activation function will decide what to do with those summation of input signal. Either I have to multiply, either I have to add it with something, whatever the things, all those mathematical equations, we generally call it as activation functions. Then the final parameter or the final mandatory requirement when it comes to defining a neural network, that is biases. So biases are also termed as thresholds. So this is very much important factor when it comes to activation or triggering of a given perceptron. So if the bias is very high for a given perceptron, say, then it takes considerable amount of input signal to activate that particular perceptron. So the bias in otherwise control the amount of input signal for which a particular perceptron to get activated or not. So on a whole, all these 6 parameters are very much essential when it comes to building our own artificial neural network using or arranging the individual perceptron. To summarize again, we have network topology, input layer, output layer, weights associated with each and every input, activation functions present in the output layer, and the bias associated with the each and every neuron. We will have a detailed study about each and every parameter in the further sessions. Now that we have already covered the network topology, we will be covering what an input layer, output layer, weights, activation functions, and biases in the further sessions.